Hello Blender folks, welcome and welcome back. This is Gnomes. Today is 6006 online workshop and we are gonna complete these bones here, the helper bones automation for the upper chest. Well, this kind of setup actually. I key bone constraint leverage setup just for the trapezium and armpit. It's optional, we can do more as much as we want for that, but we need to still be careful about stealing waves that are being stolen by these helper bones, right? So usually they require maybe except for certain features like the clavicle. Sometimes it's better to have stronger waves here because this is really a bone. It's not so fleshy. It's rigid more, so this might be good to have stronger waves along this bone. But many other things, maybe some bone structure in the scapula. It's very arbitrary, but of course there are patterns that worth understanding. So just before we start, I figured out finally how to make this automation work correctly from the all the bones. You see, this is being driven now, not by driver, but the bone constraint is working for both the tweak and for the you see this is moving. So this is moving because this is targeting the tweak and the tweak. So here we have to make a different setup. I've just made this for this particular bone. I don't like it, but it's a clear solution. I've checked, it doesn't seem to have any error. So basically what we have here is that the tweak bone here is a master shoulder. It's not parented anymore to the let's grab this, and also let's just do this for now. Yes, all right. So I'm just making this setup here for, I just want the bone data, and we don't want this, so right click, show header. No, we don't want. So just and hold control and middle mouse wheel. We want the place the relations at the top. So here we need to see the name of the bone and basically a tweak shoulder and its parent here, control chest. Okay, so the tweak bone now, tweak shoulder left, is parented to the control chest. Yeah, it could be a mechanism. No, actually not, because this is very high in the bone hierarchy, the tweak. Instead, mechanism bones would be parented to it, for example. There are two ways I found to do this, but this way is I think it's more economic. We just parent it to the control chest here, this one, right? Not to the control shoulder, and then control tab to pose mode, and then it will have a copy transforms, a fake parenting, full influence. This fake parent copy transform, so it's mix before original, and targeting the control shoulder. So instead of it being parented to it, it is bone constrained to it, and we cannot parent it to the same target. Otherwise, if we do that, it wouldn't have the transforms. So this tweaker, with this, it's working as a channel. Let's say it's channeling it's working like a buffer bone. So it's thanks to this non-parented to this, and thanks to this bone constraint, it's intaking the transforms. Even this transform is providing bone constraints through this. Bone constraint transforms to this, thanks to this bone constraint here, and then it is giving it to this bone for its automation, because we can pose it, but usually we let's here individual global, and so now what happens that I can pose it. You see it automates. This bone is automating, right? And if I pose this bone, maybe I'll not be able to see very well. Let's see. Now, if by posing this bone, somehow this will, let's reset its position, okay? It is moving and it will indirectly move this, right? So if this setup allows this, if we parented this to this as it were originally, then whether we have this bone constraint or not, it will not transfer this bone constraints pathway of transforms to the bone. So this is the one solution. The other solution would be to make, instead of having this bone with a bone constraint, instead we create a buffer bone here that will be just a copy of the control shoulder, and then it will be parented. It will have a full copy transforms to the control shoulder. Its parent might be need to this too. Then maybe this we can keep the parent here. Maybe not to the new buffer shoulder, but then I'm not sure because I deleted the setup. But that ended working, but at the expense of an extra bone. So that would not be really a mechanism bone. Exactly, it will be a secondary, a primary mechanism bone. So it's kind of creepy, right? You'd have like a first layer of mechanism bones for just this kind of automation, and then a second layer which is of mechanism bones, which is what I've been using so far for mostly everything that is mechanism bones and related. So I don't like this buffer bone, but it can work too. It can be a good alternative. It's a similar process. Basically, the idea we did here something with a buffer bone. If you remember, if you saw the previews or made the previous workshops, at some point I make this buffer bone, and this has this kind of copy transforms. And yes, it is parented to the, not to the tweak bone itself, to the target, but to any other bone actually. This parent is nearly useless because maybe it's good for exporting, but in Blender this will make a little difference because it will follow the transforms, right? So we've made this update, and because okay, so this parenting local target local space with owner orientation, this doesn't work here normally. We with the owner custom space, so this is the fake parenting setup, and this can be in this case is maximum. It's the same setup here. It's a fake parent, except that for this one the target is the tweak shoulder, and we have a very low influence. This is why it's not so it follows rotation. It's really a smooth parent relation, fake parent relation. Okay, so we can't do this with parenting. So parenting relation sucks in Blender. It's just very stupid. It's like the worst thing. Well, there's something worse than parenting relation. It's F key and I key. Yeah, it's all crap. So basically we can do a lot of that with them, but you know, it's all Neolithic age of rigging. That's garbage. Okay, let's continue. It's not Blender, right? It's the industry standard, right? Maybe in some advanced software they're doing something better. It looks like for 3D animation Cascadeur is doing something good, but I have never used, so I'm not sure. I've just seen some things. Okay, so we're trying to handle this thing the best we can. Okay, let's start so with stage 1, folks. Get ready if you want to follow up in real time. So we're gonna make the trapezium and armpit. We're gonna start with the armpit. So this is very simple because we have already gained experience with the others. We have the waves here already for the bones that we're gonna be using, and I'm gonna start by let's go to the layout. Here, what we're gonna need, we're gonna do a little different here. Feel free to adapt because I think this method is much better actually. We're gonna create, I have the suggestion that we had in a special point in space, a bone that will be at the tracking point, or let's say the mapping point for the I-key bone constraint. And so we're gonna do this time, and the results are actually good. I have them here in the stage 2. You see, this is those mapping bones here. Yeah, to my names. Okay, so I'm gonna make, so there's 2 bones for the armpit here and 3 bones for the trapezium. So the waves, really, this don't change much in the current character. It's stylized, cartoony, so it's slightly stuff that it will not be really necessary. But if we want to push the anatomy quite well and more advanced, even for more interesting organic rigging, then of course that will be a nice idea to have. So on the leverage, we can hold left click and take this off, this solo stars. This is a bone manager extension. It's free, it's inbuilt. And so we're gonna start by just picking this. No, not this one. This is a mechanism. Let's pick this one, helper scapula. We shift D, then we're gonna change it already, its name. Gonna help instead of helper. We're gonna call it armpit left. And so now we're gonna remember we have control backslash, we have the face and closest and include non-edited move rotate scale. Okay, that means that I can snap this. Okay, shift control alt Z. Let's see the overlays here, right? This is my shortcut for this geometry wireframe. So now we can shift control alt Z, right? Then we can grab this bone here on edit mode. We can hold control because this is not enabled. So hold control to snap it to the surface of the mesh. Maybe this point is good, or maybe this is too far away. Usually you would like to place bone joints on mesh joints, that is the topology centers, right? The vertices, because it's where the mesh tends to have their rotation, right? The edges would be good too, but the vertex is more profound, right? So it's more basal. So we're gonna make it here, and we're gonna make another one, extrude from the tip there and hold control. Let's try to place, we're gonna make this deep inside the, yeah, so we're gonna try to position GY, I'm doing GY, GX, then we click here, this joint. If you cannot click it, then C, yeah, and select all, C, left click, right click to cancel and leave the selection, and G, let's grab this, and so let's put numpad 1, go on front. So we don't want this bone to start this way. Maybe this will be a bit weird, so we want instead, yeah, it's good to follow the mesh, but sometimes it's not that good. So these are helper bones. We can do really, there are different things here would work. So let's make this one smaller. Like maybe I want this one to go down here, something like that. Really, there are different ways to do this. So I'm not taking too much care here about being anything exact, because this is really arbitrary. The fact that the bone is starting in a weird rest position, in this case, it won't really affect the deforms so much. Like it will still do its job, even if it's offset, even if it's crazy, as long as the way it deforms is correct. Yeah, because if it's, so here we're gonna, yeah, control 3 to show the axis. It's another shortcut. We're gonna reset the roles for this. Let's select both of them, shift select and shift H. Let's just look at them. So usually I want the Z axis to be pointing towards the face. So control R to do these rotations. We can also align here. So shift select here. This needs to be the active. Shift N, recalculate role to active. There we go. So, and here we can maybe do something like that. Yeah, so it's very arbitrary. Here, let's try to centralize this a little. And I think this sort of angle, yeah, this seems good enough, because I'm considering how it should stretch and all that. Maybe this is a bit too far away. And now is there where we're gonna make the other bone. So we're gonna, yeah, we're gonna reuse here. We're gonna extrude here. And this bone, we're gonna change it to Shift Alt B. Gonna change it to stick. So now we're gonna change its color. I like for some of this viewport display on bone tab. Let's use this this thing here. It's too big, so let's reduce here. Alt R, let's reset here. Let's show the skeleton, and I want to have it completely aligned. We're gonna rename it F2. So we're gonna map armpit left. All right, we're gonna. So this is the I key target actually. So we're gonna select it. Shift select the mechanism upper arm left bone. Control Alt A to get full aligned. So why is that? Well, because this will sort of, and also you're gonna select it and shift select it, and again, sorry, Control P, keep offset, Control 2 to look at the overlays of relationship lines. So you see, and let's collapse this. So you see that this bone is now parented to the upper arm here, right? Map armpit left, this one is parented to here, offset, and so it will follow by parent. So stupid parent, but that will work for the, it will follow the mechanism. If the mechanism stretches, because it has a stretch to bone constraint, it will also stretch. So this could be dangerous, but the waves are so low here that this shouldn't be a big problem. Actually, this is not a deformed bone, so let's tab here and take this off. And now we have this one. We got, this will be the I key target, so we're gonna use this other theme here. Let's make it sorry, Control Alt space, no, Shift Control space, I click, no, Shift Control space, Shift Control. Okay, there's a shortcut here. Shift Alt space. Okay, Control Alt space actually. Sorry, this is terrible. So if you can be stuck in this forever if you don't know how there's two shortcuts for that, but one of them is easier to, this one is the hardest to get out because there's no button here to return. Control space, I have back to preview. This Control Alt space doesn't have this, so wow, what's happening? Okay, let's go back here, folks, and we're almost done here, but the problem is that since I've duplicated those things, they have some inverse kinematic settings that we're gonna have to take care of. So, but anyways, let's select this. We can do this on edit mode. Still select the, we're gonna make the I key bone constraint. Select the map, then shift select the helper, the last one, Control Tab 2 to pose mode, and then Shift Control C to add bone constraint with target, inverse kinematics. Now we go here to bone constraints tab. We want a chain length of, you see I have the control line, so it's not 0 infinite, no, it's 1, it's 2, it's 2, not 3, not 1, 2. So no pole target here. I haven't tried with pole target, so feel free to try, but I don't think this, I don't see very well how it could be useful. Maybe on the, maybe when the bones they start to bend in some weird ways, then maybe you would like this, but then there are other ways to compensate for that. A pole target could be a bit bizarre, but maybe it's could be useful. I don't know. We're gonna take a look at the armpit, but if we have time, but just curious, but for out of curiosity. So here, this is already working, but we need to reset some things here for the inverse kinematics panel. Okay, this doesn't have anything, so this is clean. And this one, we're gonna reset those things because we copied. And also because we copied on pose mode, it also have a copy transforms for the tweak shoulder. So the tweak shoulder is here. We can hide this mechanism for now. And now we got, we can pick this bone. You see what is happening? So we have, I'm not sure there are, Control Tab here to object mode, Control select the mesh object, Control Tab 7 to wave paint mode. Let's look at the waves here. Alt left click. Okay, they have waves, so I've named them correctly. So these are the waves. You see, not strong waves. This is really, yeah, they are a bit hard to be moved, but we see that they do something, right? They do something to the mesh. It's very minor, but it can be cool. So select this, back to pose mode, right? So select this. You see that these are probably contributing to some deforms, right? And what we want is to improve the positioning, the transforms of the bones. So for example, of course I'm making some crazy poses here, but you see that this is not good, the way this is stretch. It's not stretching. So I'm gonna add some stretch to this one. So tab, bone tab, inverse kinematics panel. Let's add a little, just a little of stretching here, something like that maybe. And then we gonna check here. Okay, this looks good. All right. The other is moving up. Is this good? So here is a bit complicated because we need to pose the arm to see because the upper arm rotates a lot, right? So we need to be careful to be able to test many of those poses. So what I'm gonna do is gonna save here. I'm gonna make an animation here, an animation action. So I'm gonna hold left click here. Let's drag this down or up, whatever. And then what I want is that I want this to be the Shift F12, right? So dope sheet editor. Let's change here to action editor. Let's move this down here. Let's do something here. I don't know, I have an action here, so let's add an action here. I'm gonna save this action. This will be like arm, test arm. Yeah, that's it. Armpit. Yeah, that armpit. So that is gonna be like that. We're gonna insert keyframe to just let's make something here. Yeah, I want this. So Shift H here. So gonna save here. Gonna insert keyframe with all this selection. I. Then we gonna move this forward. So I'll start with moving this up, and let's also move this up. Why not? Rotate also. So a lot of transforms here. Okay, so this is an exaggerated pose already. So we're gonna insert here. Let's okay, so now it's doing here. If we hold if we drag the left click here on the timeline of the action editor, then we want to select all Alt Q to clear all transforms. Then let's move this down. You see that we have very creepy things. It's not very anatomic. So certainly, although this is not affecting too much the mesh, it's still deforming in a way that is ugly. That is not gonna be good. So we want let's pose like this. This one we don't do anything too much. So we're gonna select all, and actually not all, just this, and insert keyframe. Did this accidental mistake, by the way? Summary. No, we haven't posed. Oh, we have posed. Yeah. So we're gonna take off the map. Yeah, these three first bones. We're gonna delete this helper, just the two helpers and the map. Yeah, we're gonna take off their keyframes because we just want the channels of the control rig just to prevent some mistakes. So in here we go drag here the left, actually up and down arrow here for navigate between keyframes, control and here, and there we go. So now we can easily make this test, and shift left or shift right on the timeline here to do this thing, to go to the very beginning and the very end. Okay, let's go to the very beginning. Now we're gonna go here. We can hide the geometry, maybe it will be better. Let's try to look here if we get anything like cavity. Maybe this will help a little. Sorry, it's a solid viewport shading. Okay, we got some problem here. Shadow, yeah, let's enable the shadow. Let's augment the shadow. Let's screen, no, both. Let's augment this ridge, this valley, this thing. Okay, yeah, this is not helping too much, right, folks? So specular lighting, let's leave this on. Outline, that's okay. Then maybe we need something better here. Oh, yeah, I have some presets here for another project, but maybe matte cap. Yeah, maybe we can use something. Yeah, let's use the matte cap for now. It looks a bit more shady. Okay, let's Shift Control Alt Z to enable this. I want this to wireframe. Where's the wireframe color? random. I think random is a little better in this case because it was too dark. Okay, so now we're gonna look what we can do here with the so this bone, because of the parent, it will just be like that. I'd prefer it to be a point in space, but no, it's not a point in space. So here is where we can take advantage of the axis very clearly for the inverse kinematic setting. So what we're gonna do is that we're gonna pick the this bone first. We're gonna try to, okay, have some stretch. You see that if I augment the stretch, it starts to bend in that weird direction. We don't want that too much. We can prevent it by making the x-axis rotation more stiff. So stiffness of the x. Oh, sorry, it's not this. Okay, so instead, let's use this one. Okay, so we want the stiffness of the x-axis for this one, and we can make this one more stretchy. So maybe it will help preventing some problems. So we're gonna, let's see about this. So there are many setups, of course, a lot of combinations of setups that would work. But I think here, this one, you see what it does from a front view. Numpad 1, you see that the stiffness X makes that this bone is very hard to go inside the chest. So it keeps, it's not too much though, right? I maximize the stiffness. That sounds good. So it still have this rotation. Let's see what it does if we, yeah, you see, oh, I was looking, we need to go to the very end, right? So yeah, you see the stiffness, the basal one, we want a lot of stiffness. So something about here should be nice, right? And as for the other one, because it is parented, connected, right? It's already, we can have for the x-axis maybe, yeah, maybe just some stiffness like this, I guess. I don't know what's really happening here. They are sort of crossing. That's going a bit crazy, but it doesn't mean that it will cause horrid deforms. If the waves are low, it's just maybe could be even beneficial. I'm not really sure. So maybe this bone is having some problem with its y-axis. So let's augment its, no, it's not about this one. So maybe let's try its, okay, I'm augmenting the, it's this bone, armpit, the one with the IQ bone constraint. Let's try to augment its Z, no. Okay, I've augmented a little here, okay, let's try this. Let's reduce its stretch. Let's augment its X, no. It seems to be rolling, right? But this doesn't seem to, let's leave something here. Maybe this one is rolling. Maybe it's rolling a little, so yeah, it's rolling a little. So we're gonna augment this Y stiffness. And for the Z-axis, we are gonna just leave a very minimum value here, because maybe that's important, okay? So you see, there's a lot of stretch for this bone, but that seems okay. And then we're having some problem here. So maybe here we could possibly fix this if we go tap to edit mode. Maybe I need to bring this GX further away, Shift S2, no, Shift S3, cursor to active, and then select, grab this joint with the select, unselect all, C, left click, alt click, and then Shift S, selection to cursor 8. There we go. Okay, so now we have a little problem here. We're gonna, yeah, select both of them. Let's change the transform pivot point to medium point, GZ. Yeah, let's do this. Maybe this will improve a little. And this one, this joint, GZ, GX, something like that. Yeah, let's try this. Maybe this will improve a little. We might have to, the animation is the same, right? So these bones, these helper bones, don't need to be outside of the, on the surface. They can be inside of the mesh, right? So what is, the Z-axis is if the rotation like this, right? So Yeah, just a little here for this, a little for this, and the stiffness X we already assessed. So now I just see about the, let's see the stretch. Yeah, this stretch is fine like this, and this stretch, we'll keep it. It's very important to see the stretch in, like, for example, here in this exaggerated pose. So I think this improved a little. Let's see. Yeah, you see a lot of stretch that will minimize, and this can maybe cause some artifacts, but because the waves are so small, this doesn't seem to be tragical. So we want maybe too much, a lot of stretch, but not so much as the bone disappears, collapse into itself. So something like this sounds good enough, right? And as for this one, another thing we can do for this one, it has a bone constraint. We can also augment this. Now this can be dangerous. So yeah, we want really very minute thing. This is not even necessary actually. It's because how can we achieve this? Okay, we could achieve this instead of using this with a mechanism helper that will not be deforming bone. So it could stay in place, but it will stretch. You got the idea, right? Because imagine it was this bone, the mechanism one. So it stretches, and so it moves the base, the head, the root of this other one, the following. So which would be the first deforming bone in such case. And then you have other bones until we reach the map. So yeah, so we could do this instead of doing this, right? So it could be more satisfying, I don't know. But this also is cool and it works, so it's fine. But maybe that will be more economical, right? Yeah, so interesting ideas there. So we're gonna now, this is for the armpit, folks. Nothing else to see here. This is done. We can, okay, so now we want the trapezium, which is the last one here. So they are hidden, so we're gonna bring a copy of this, and then we're gonna copy, yeah, let's copy all this, right? Except that we're gonna grab this, yeah, select this, shift alt here, help armpit, shift alt this one, map, shift H. Okay, we're just gonna start with this. So the parent here is already correct, is the deformed chest. We are gonna grab this head, we're gonna snap it to, now it's important, this depends a lot on the anatomy. So this anatomy in this region is a bit poor, unfortunately, so there's little we can do here with this one, but yeah, we can experiment anything. So I want this to be maybe in this case not so much in that part, so I'll make it here. So this is what I did before, Alt R to clear, reset roll here, clear roll, and we're gonna make a roll maybe like that, yeah, I don't know, pointing up maybe, just like that. Okay, then we grab this, we're gonna connect it, shift select this, sorry, the bone here, shift select here and connected. And now we're gonna grab this, we're gonna make another one actually. Yeah, so we're gonna pick this one and subdivide it. So now we have this. We're gonna rename these things because they have poor names. So Control F2 B for bones with all of them selected. Then we want find replace. Yeah, we want, instead of armpit, we're gonna get trapezium, which is the group muscle group of this region. And then we want to add something here. It's strip character, hold shift digits punctuations and click and okay. Now we got this ready and we want to reset this. Okay, let's reset all and then we do manually. Maybe this one like goes like this. I haven't thought really which is the best role for this, the automation, right? The stiffness especially. But that might be okay. So here we want maybe this, we want this bone to also be aligned with the mechanism. So we're gonna select it, shift select the mechanism upper arm, Control Alt A. Okay, it was already aligned with it. So you just want to position it in some strategic, Control Numpad 1 to see from the back. You want just to position it G in some place that will be nice for the trapezium muscle to follow. So you could do anything really, but I will try to keep it about here, maybe more in the middle. Yeah, maybe about a bit more up, maybe about close to, yeah, close to this joint, also close to the upper arm surface, but about here. It's close to the back also. So here we're gonna Shift S, cursor to active is 3. Then select this, grab this one, this joint, the tail, Shift S8, selection to cursor, and there we go. Now, yeah, this orientation seems fine. I'm gonna reposition. Yeah, let's hide now this mechanism collection. Let's hide all this. We just want these bones for now. Now what we want is to reposition this. So Alt A to unselect all. C, click here the joint. Let's bring this, grab here about here. And yes, this could be this larger area, maybe about here. Let's hold Control to snap right onto the surface. This one we're gonna see here again. Yeah, so it's Alt A, unselect all, C, left click, right click, G, and hold Control and yeah, and step it maybe about here. Yeah, let's place it here. All right, so I'm gonna make this smaller, and right, this is the Ike bone target, so owner, right? Ike bone constraint owner. Let's tab to, let's see if the parenting are correct. So this is parent to the deformed chest, this is parent to the trapezium, this is parented to the, okay, their names are weird though, they are inverted, so we're gonna change here to 3, this one we're gonna change to 1, and this now we go back, change to 2. All right, and this doesn't have any name here, so we're gonna get now the on pose mode, Control Tab 2 to pose mode. And so now let's check. Also Control Tab, select mesh object, Control Tab 7 to wave paint mode. Let's just Alt left click here, left click here, left click, Alt left click here. Yeah, so indeed these are the waves here. You see, this is very simple, not very strong waves here. So some helper bones can really have stronger waves, like I've mentioned in the beginning. No, not so much more, right? But you see, it's stronger waves than this one, slightly stronger, right? So okay, Shift select, sorry, Control Tab 4 to object mode back there. Let's select the armature object, Control Tab to pose mode, and now Control 3 to hide the axis. Now what you're gonna do is that tab to edit mode. So you see that these bones probably hold some weird stuff. So this one is correct. You're gonna keep this. Let's see what it does by just animating. Look at its head position. Okay, we're gonna try different here, just because this can be didactical. So we're gonna make a mechanism bone for this. It will be Shift D here. Actually, no, sorry. Gonna delete this. We're gonna subdivide. So we're gonna pick this joint here. Shift S, mark the cursor here. Now grab this bone and place it maybe here. Let's grab Alt A, C, grab this. Left click, then right click, grab, snap to maybe here, that's enough. Then Alt A, C, grab this, left click, right click, grab and snap it. Okay, now we actually, sorry, validate, but Shift S, snap to selection to cursor 8. And so now we have this back. So it's exactly on the same position as it were. before, so the roles are okay. Okay, we'll accept these roles. Let's reset these roles. No, let's, for this one, let's make this roll maybe more like this. Okay, so they have some, they are rolling, right, in some way. Yeah, they are rolling in some way, although to make sure this is coherent, this is augmenting. So these are positive rolls. Okay, they are visually correct and mathematically correct in terms of, this is not necessary, but this is a good practice in the case of working with bendy bones. So this one we're gonna change to mechanism, trapezium left, and we're gonna change its bone tab, viewport properties. We're gonna go here, there's a mechanical bone. Let's delete this thing. This one, it has a wrong name, so we're gonna F2 here and return this to the original, because it was the duplicate when it's subdivided, unfortunately. Okay, so now we're gonna, the waves are the same. Control tab 2, no, control tab, select mesh object, control tab 7, shift, no, sorry, alt left click. Okay, we got a problem here. These waves took the name of the bone, so this is a little problem here. Let's cancel this. It's called the mechanism trapezium, right? So actually we're gonna change this vertex group to help trapezium and validate, and now alt click here and alt click here. Okay, we've just changed the yeah, transfer the waves between between bones. Okay, control tab 4, control to object mode, select the armature object, control tab, now control 3 to hide this stuff. So we're gonna leave this bone, shift control alt a little more like that. All right, control 3, yes, its head is there. Okay, so let's look at this bone constraint. We're gonna delete this we're gonna, okay, so hold on, control Z, we're gonna actually select this bone, shift select this, and shift alt C shortcut to copy constraint to selected bone. So now I will delete this one, but I'll keep this one here, even though it will be inactive, just to have it in case we want to reuse it later to compare. So right now we want that it is parented, right? To select this one, it is parent to the, connected to the mechanism trapezium. I see connected parenting. This one is then, okay, it's a full F key chain here, but it's also an I key chain because we have now an I key bone constraint. So you're gonna use the stretch again. So I'm gonna check here the inverse kinematics panel and here. So we're gonna, this one we're gonna reset those things. Yeah, reset everything. Oh, this is a wrong value. Okay, let's it wouldn't do anything though. Let's reset everything here. They took this from the, they took this from their duplicates before. So let's try now with the animation we've got. Okay, so you see I think I'm missing the I key bone constraint chain length. Yeah, it's 2. So we want to augment to 3 and maybe even to 4 in this case because we have a mechanism. Ah, there you go. Ah, you see, this is also works. Although it's not moving its base because it's not a deformed bone, it doesn't really need, as long as this base is moving, this root, this head is moving, this can be good. But we want this one start, let's stretch this, the mechanism, yeah, so now it can push or drag according to needs. So that's very interesting, right? You see, its scaling don't really affect directly the scaling of its child. So very interesting behavior, right? The I key stretch here. It's just changing the positioning. I don't think this scaling is affecting the other because we see that only itself seems to be scaling. We can change this even more, right? So we can exaggerate this. So, and the fact that it's shrink like that is also not a problem, not at all. It's weird, right? So maybe we don't want that, but right. All right, maybe just a little more. All right, something like this. Okay, new technique. So this totally works, but we need to see, we don't want maybe this bending. So let's see control 3. I think this is the z-axis. So we're gonna give it some stiffness on the z-axis like this. Because in the neck, I don't want the neck to be deforming. Like I don't want this to be balancing, how to say, from side to side too much, right? So it's just very stiff in the, in that, in its, yeah, right, it's not doing this RZ. We're gonna change here to local RZ, yeah, RZ, right? It don't seem to be, well, I think it's the bone constraint is affecting it. Okay, anyways, so this is, seems to be good, but let's look at other things. There's also this X, let's see. Yeah, we also want some stiffness on the X. Yeah, something like that. We don't want it to, we want it to stretch, but about the y-axis, let's see. Yeah, doesn't do nothing for the first bone in the, very weird, right? I don't know, it just, oh, here you see, there is some twisting, but it's really, it's so little, I think this is not a problem. Okay, so now next one, so it doesn't have anything. Let's try to stretch this and let's see what happens. Okay, this can be interesting. Oh yeah, okay, so it is compressing because I think we need to add some stretch to all of them first of all. So we see them interacting in different ways, right? Let's also look just at them, right? Shift H here, Control 3, Control 2. Let's look at this stuff. Wow. Yeah, so this is very interesting, right, folks? And basically, what I can say, mostly this one is behaving adequate, but what to, maybe don't want too much of the, again, the Z. So we're gonna not lock Z, but just give it some small amount of stiffness. This one has a lot of stiffness on the, just a little on the X. And you see, so the neck, it's stiffer in the neck. This Y doesn't seem to be anything, right? So yeah, here there's a little, but the Y we ignore. So apparently it's more on the Z axis here, right? And so I'm still not familiar enough with when building on edit mode what axis, but by doing this the way I'm doing, pointing the Z axis outward, usually we can work with that. So here for this one, let's jump this one, and I think sometimes starting from the end, the first in the I key chain is better. This is the last on the I key chain, but the first on the F key chain of the parenting, right? And this is the first of the I key chain, but the last of the I key chain, and then the last on the I key chain is here, right? So I key chain length of 4, right? Okay, so let's see if this stretching, what we can do. Let's augment the stretch a lot. Let's see what it does. Maybe this could be good, right? This collapsing bone, you see, it doesn't, it is a deformed bone indeed, all of them, and it has waves. You can double check here, right? Yeah, it has a lot of waves actually, and you see that very curiously, this total collapsing of the bone trike, it's stretching. I don't see it destroying the mesh. Maybe if the waves were very strong, but this can be dangerous still. So we're gonna I key stretch, yeah, I think it's stretching that much also because of the posing, but because of this one has a lot of stretch, right? Yeah, so it's stretching and it's overtake. So there's something that it's complementary, right? They need to work in sync, so for the good automation. As for the rotations, this one rotates sort of wildly, which is good. Maybe you want this to rotate. Yeah, it's free to rotate along the... I agree with these things for the trapezium, right? We don't want the trapezium to go up the up the hill here of this crest of the shoulder. We want it really the muscle to stretch towards the back, all that, right? We could have more of this if you wanted to emulate something. If you have better more complex mesh topology here and geometry, you could do more stuff. But you see that this seems quite good. And if we can test also shift select all these three, toggle this off, you see it's very minimal, but in certain areas, because this is like this presentation is like it's just to see what we can achieve to improve, and this will certainly help if we don't make something very crazy. Instead of disrupting the rig, it will probably make the rig better in very complex posing region here. And of course my rig here suggests that I should be able to rotate something like this. So you see these helper bones in a pose like this, they probably, I believe they are being beneficial. No, not too much, right? So we have also the scapula here. We have fan bones. Yeah, you see, things start to get a bit ugly, but very tiny here because we have a lot of work here already, right? Then we have the fan bones, which also developed in all orientations, right? So, oh yeah, the fan bones are really very important here. And by the way, I'm not even using the subdivision surface modifier here. Now I am. Yeah, Shift Control Alt I for the simplify. Yeah, without deforms, with deforms, without deforms, with deforms. Yeah, like we can do way more, but you see, this is a good concept, I think. This shows that we can use Ikebone constraint famous for the for control rig, but we can also use for the deform rig in ways that we can you see, the anatomy of the body is very complex, and the rigging techniques we use, they don't really follow, in my opinion, the anatomy complexity. Of course, it's just virtual, it's not smart enough. So what happens is that we can use, for example, for the leg, the Ike in the rig that I have, you see I have this bone, so this is also affected by inverse kinematic if we want. Of course, it's just one side of the hip, right? So this is unnatural, but the fact that this ball joint here, it's really a ball joint between the femur and the pelvis. There's a ball joint, ball socket ball joint, or ball socket joint, yeah. And this joint, apparently, it really changes as the bone rotates. The ball of the femur, which connects to the socket of the hips, it really, there should be some motion, slight motion. So it's not like the femur is stiff. No, there is really a small displacement, not of the hip, but of the ball. So the femur as the leg, it seems to have some slight repositioning, a bit like this bone allows it to do, but not like this, of course. It's very subtle, maybe about millimeters less, maybe, but it does. I'm not sure, but it seems to be the case in that kind of ball socket joint. Okay, and because of that, we would ideally want to have some inverse kinematics. Not for the control rig, of course, we just moved on the leg, but for the deform rig, something that moves here wants something up there to move, right? Sometimes, and vice versa. So that's this is why it does make a lot of sense to use something like some automation, smart automation by like inverse kinematics for organic rigging for this kind of deforms as well. So yeah, so we can use these mapper bones for specific points in the mesh, and they can follow by just parenting, or they could instead have some sort of fake parenting setup like this, or anything you name. But this is really interesting because we can vary the influence, right, with the fake parenting bone constraint, right? So right now these ones are very simple. They are just following. We can pause them, of course, and check different results. So that's actually interesting because we could combine. I just got this idea, folks. Actually, we could combine. Why I'm doing this? We have already posed an animation. So for example, but I don't have a last animation here, folks. Like I don't have a pose here for the back. Maybe here I need the control. Yeah, there's some bolt target here. No, it's this one. Okay. All right, let's do this. Okay, let's just insert keyframe for everything here. I don't care. So basically what we see here is that maybe we could use these bones as to automate automate an automation, right? So we could have them use some, let's see what we could use in here. This is kind of crazy, right? But we could give it, for example, the same Ike bone constraint of this tweak, like a shift. So instead of using a transformation bone constraint, which doesn't, it's simplistic, it's very stupid because it leads to, it's very cool, but it's too analytic and it leads to the problem of the deltas. While when we have something that includes the rotational ball system, like for example the fan bone, right? The fan bone rotates in all x and z plane orientation, so it rotates x and z. It does all the RR, it does everything, right? So yeah, it doesn't twist here, but we can make it twist too. But here that means that the idea is that we can have some amount of automation based on rotations, and for this we need a system that includes x and z, like the fan bone. So we can sort of mimic that global rotation, let's say like that, xz rotation, which won't need deltas because it's natural, right? It's not stupid. It's not analytic stupid. It just knows where to go because it's really 3D-ish. So it already knows the diagonals, so it doesn't need delta. So theoretically, I think this is correct. So that means that if I pick this and shift Control C, add bone constraint with target. Actually, sorry, not like that. Let's just copy. So Shift Alt C here. And of course, we don't want this target. We want this target, F2. But this is not enough, right? We want to reduce this influence here. Also change here. Control C, Control V, okay. And so we can have some ballistic rotation of this bone, like you see, it will retain its automation of the trapezium. What I picked here, I think I picked the armpit. Okay, never mind. So let's pick this one and do the same here. Okay, so now this one has got this all right, and you name it. You can also use the fan bone, which already, this is for the fanny bones. This is the last technique we're gonna employ right in the next session tomorrow probably. So we see here that this can automate the target, the mapper. So and it will follow the orientation of of this bone. So whatever this tweak bone that the master shoulder, let's say like that. If we can even pose it manually, the other bone understands as a parent, right? Because of the fake parent, so we can reinforce. Now, of course, we don't want that much, so it's very subtle, but it's a ballistic motion. So, for example, Control 4. Let's yeah, we won't see the bones properly, but I rotate this. You see, the bone follows. I rotate like this, it follows. I rotate like this, right? Local space. I rotate X. I rotate Z. I rotate Y. So this is the ballistic rotation, and it's more than that. It's a ballistic rotation that follows up different, varied influence. And so we can use this trick to prevent deltas, to substitute sort of the transformation bone constraint. Of course, the transformation bone constraint has advantages. By being analytic, we just can say, oh, when the shoulder goes backward. But this analytic then will have eventually problems with delta, which is nightmarish. Like it's solvable actually, but it's very bizarre. And really, if we had a system like this one that spontaneously do this stuff, it's actually very cool, I think. So of course, the problem, since this goes in all directions, right? It might not be great to have it too strong, or on all there. It could break certain things, so you need to test in a lot, right? Or sufficient, at least on the critical things. So right now it seems to be doing some job. Also, let's look at what's happening here. So this is the trapezium. So to prevent this, sounds like terrible. Let's hide some stuff here, right? Yeah, so this seems to be moving too much, right? And it seems to be displacing from, maybe we need to place it more inside the body, right? So I think just changing this won't cost too much, right? Let's grab this GY, global orientation. Okay, let's see this. And yeah, this looks like more natural. It's important that we see this. And here is where maybe we can play with this more with this the inverse can have it. So let's see more stretch. Now let's leave this stretch as it was, but maybe here let's see this stiffness. This one doesn't seem to respond anyhow any good, so maybe it's about this one. I want to prevent it to rotate too much. It's along the z-axis, right? Yeah, so maybe we want to prevent them for a lot of z. Augmenting this z. Okay, so you see this maybe, and also for the x, let's see what this x does. No. Okay, more x maybe. Yeah, anyways, we got the idea. Let's check again. This very radical poses. They seem to be working, right? Subtle waves, they won't do too much, right? So, and we can have indeed this automation here. We can extrapolate, see what looks better. Oh, this actually seems good, even though the bones start to get a bit too much offset. Maybe we want more waves for this one, right? So, and this, let's try to push this. Yeah, even in real time, let's try to. Let's grab my. Yeah, I'm gonna use this brush, Shift X here for these waves, F. Let's reduce this. Let's do something like this, and blur. Let's blur all that. This is exaggerated, right? But we're gonna see the results. Maybe we can get some. Also, this could be a good moment to affect the other side of the mesh. So this is a special technique. With mirror modifier is a bit tricky to do. I feel like it's good to have waves on the opposite side. So we need to symmetrize all this setup, right? So we're gonna control tab to object mode, tab here, select the armature, alt H, select all, and actually just this side here, control 3, alt H, making sure nothing is hidden. Okay, we're gonna symmetrize everything here. All right, then we're gonna control tab 4. Now we're gonna go back here, save, control tab for the armature object. Sorry, it's the mesh object, control tab 7. Now, for example, I have this bone. I cannot paint on the opposite side, although I would like to. So instead, let's click Shift Alt X to invert. Is the select. Well, there's no option here, but is the select mirror, right? Without extend in this case, right? I just want this one now, and now I can pick this wave. So it's Shift Space Bar Paint. And the paint is the brush. I see Shift Space Bar, this paint here, not. And then let's reduce with F this. Let's paint with the mirrored. This is the mirrored side, the right side of the character for me. We're gonna paint some waves here on the mirror and also in the middle here. So this means that we're gonna, I'm gonna blur this. Yeah, I'm gonna make something like that. So this means that now when I pose, when I Shift Alt X is my shortcut actually, you see now these waves are mirrored there, the ones that I've just painted here. And to erase it, we need to have on the mirrored set weight to 0, Control X, and now it will Shift Alt X. It is, of course I don't want to destroy this. Shift Alt X. Okay, we maintain this. So I cannot paint these waves here on the mirrored side. I need to be Shift Alt X on this bone, and I can't paint here still. I need to paint here. So that's crazy, but that works, right? Shift Alt X. So let's continue here. Also, I'm gonna do some for this one. Let's Shift Alt X here, and let's just blur here. I think no, I can't blur. It needs to recognize some waves here first, and then we can blur. Yeah, it needs at least one vertex painted on this side. Okay, yeah, this is very crude, but you get the idea, right? We can do this, and then for this one, this is a mechanism bone. Then there's one little here. Yeah, let's this one, Shift Alt X. Let's Control Space Bar, Shift Space Bar Paint. Let's Shift X. I want this amount of weight here exactly. Wait, did I press 4? No. Wait. Oh, wave 0. Sorry, it's Shift X. Oh, of course, because this is mirrored. Shift Alt X. Let's return here. Shift X here. Now you have the waves. Shift Alt X, and now I can paint here, and we're gonna get even here, and that should be good. And then we're gonna blur all that somewhere like here too. Fine. Then all this, and there it goes here, and that seems good. Yeah. Not really too attention now what I'm doing, just good enough to see some quick results, right? We can be way more careful than that. So Control Tab, this is enough. Now we're gonna check something here. So you see this deforms a little, maybe not the way that we want, so but it's a principle. So we can make waves affecting the opposite side, or in principle, the way the bone moves, it will still behave. It will just push the mesh the way the bone moves, right? Exactly. Seems a bit junky, but you know, that seems to be natural still. All right, folks. So what is this? Oh, there's a pose here. So you see that although the offsetting of the bones, it doesn't really destroy the mesh as the... Well, there is some destruction there because I've probably painted too much there. So we need to be careful. Oh, here is actually a good notion that we should be careful about. Oh, yeah. We should be careful about the... You see where... the x-axis, right? Yeah, this x-axis. It's hard to tell because it's oriented. Let's do something like here. We're gonna make the x-axis more like here. Yeah. We're gonna try to align them like here. And here, yeah, this will gonna disrupt a little our previous work. But out of experimentation, so the x-axis pointing up, and in this way I will try to prevent for this particular bone a lot of stiffness on the x-axis. I want to prevent this bending here. It doesn't seem like I'm very successful. Oh, it's because, yeah, maybe this one. Okay. No, this also has lock axis. Let's see. No. Am I doing this right? Maybe I'm confusing with the... Anyways, the fact is that the one bone needs here to be going up like with follow this, right? So you see this one is working. It's not moving, right? It's not rotating like that, right? But it's not enough because then this one is okay. Then, but then now they are stretching too much. Hold on. This one has already... Oh, did we didn't change this one. Okay, sorry. Let's align with this one. Shift, yeah, like this. Yeah, we don't want it to be... Sorry, I'm going fast here because essentially I finished the thing. I just want to see... Yeah, so we want to reduce this I key stretch to see... I want to try to prevent the big block to do this. So apparently this is still rotating a lot, right? So let's augment its X stiffness. And now this one is also... It seems that it's never enough, right? So maybe... Maybe we need also some y-axis, so because as the bone start to roll, it start to change its yeah, so this one now it seems to be... Yeah, unfortunately I'm destroying the... So here I don't really know why. Let's lock all the axes. It's still rotating wildly, and it's not a question of having a pole target here. So I'm not really sure why I can't really control the... It doesn't have the I key bone constraint, right? The I key bone constraint is here. So yeah, so I was good at fixing those, but you see, this offsetting is not destroying the mesh, right? Because the waves were careful enough to not let them too tough. So you see, this setup, this kind of setup can be easy in some cases and more difficult in others. And it's tricky, but in many cases it's kind of funny, and I think it's kind of very effective because it's not that hard in many cases. Can be... What is that? Okay, some rogue wave there. We don't care. Anyways, folks, this is the, here represented different uses, right, with the mapping. And hope this was enjoyable or interesting at least. This is for today. We finished the upper chest, all the upper chest leverage setup, right? But now what we need, the next will be the Fanny helper bone setup. Not fan bone, I call this Fanny, which is for something surrounding. It will rely on the fan bones already that we have, but it will, yeah, these ones for the shoulder joint is a complex joint. We're gonna build the Fanny bones that will work all around the shoulder region, which is anatomically very complex joint to solve in organic rigging, because the upper arm rotates in all directions, and so the shoulder, and then this cause lots of skinny artifacts of the worst kind, and it's very hard to fix because there's no big symmetries there. The anatomy is not at all symmetric. The best symmetry is the front and back side, but it still is very bad. It's not like an elbow or a knee, so it's very complicated to, like, you need to treat every direction individually. This is why we need not one fan bone but many Fanny bones, and which one of them will be automated in a specific way, like a corrective shape key that would be that will solve like corrective shape keys, but it will solve, they will solve like geographically, locally, each one of them follows the major fan bone, but they will have their own deforms. Actually, we could even turn this fan bone, they'll be parent to the fan bones here. We can also make from here. I don't have experience with this one. I use this one, but this could also work. But I think this will be double work if we made Fanny bones for this and then for this. Here, really, I don't know what is better, but let's use this one to start with. And if we see any advantage of using this one as a parent, then we can do, because differently from parenting to a mechanism bone or a whichever thing here, this is already a derotator bone for the Z and x-axis, this plane. So it is already a derotator. It offsets from the mesh itself. It derotates the mesh on the joint region only. And so but it's not enough because of the asymmetries, anatomic asymmetries of the complex joint of the shoulder. Same happens in, for example, the hip thigh joint. So by making these Fanny bones, I didn't create this method. This is from at least 2004. Some professor of Australian professor, I think so, Freeman, some guy named Freeman, already make some sort of article on a 3D World magazine that contains in master animation software. It's a software that exists for rigging and animation, presented there on that software in an article on that review, 2004, so a long time ago. The technique, the method of the fan bones, and then sometimes it's called fan or sometimes Fanny. I don't know the real difference. I've read that article, it's very old, and it's like it's an analytic method for solving weights. So it's a very smart method and very incredibly, I don't know, took me a while to get in touch with this, although it's more than 20 years now, right? So anyways, it's not super popular, but probably it should be more widespread by this time, I guess. All right, so that's it, folks. So we're gonna do this setup here. We have the base thing, and this is just like minute details, but they could solve some of the harsh artifacts that are still having, even for the armpit, if we address just from the bottom. So this is where we could use possibly transformation bound constraints, but then there would be problems, yes, with deltas. We might need to investigate that further. All right, folks, I'm still trying to investigate a way to prevent deltas, by the way, with this approach of the ballistic rotation, like trying to get some bound constraints, some funny bounds, for example. Instead of just following this, they would try to and automate in various ways with additional automation. What about having them automate according to, right, three-dimensionally, instead of just like solving the delta on their own? That's it. That will be big stuff if I can find. I have an intuition. I think this can work, but I'm still trying to figure out, to conceive how that would be possible. So that's it, folks. Thanks for watching. Take care. Happy blendering. Have a nice week. And we'll see you next time.